Hey guys, welcome back to my channel and this is Varun. In the earlier series of videos, we have covered a bunch of topics related to inferential statistics, wherein we have tried to infer the population mean given the samples and its parameters. Now there is another dimension to this. We have to confirm what we have predicted, right? And that is the part of testing. So starting today, we will look at what is called as hypothesis testing. Now sometimes you have some starting assumptions about the population mean, and you want to confirm those assumptions using the sample data. So this is what is called as hypothesis testing. So today we will cover some of the topics such as types of hypothesis, types of tests, decision criteria, and critical value method of hypothesis testing. Now, as we saw earlier, inferential statistics helps making the inferences about the population using the sample data. Okay, and now these methods will help formulate basic idea or conclusion about the population, and such assumptions are made by hypothesis testing. So we will differentiate between inferential statistics and hypothesis testing. So inferential statistics is used to find some population parameter, mostly population mean, when you have no initial number to start with. Okay, so you start with the sampling activity and find out the sample mean, then you estimate the population mean from the sample mean using the confidence interval that we have seen in the previous videos. Okay, and hypothesis testing, we yet do not know the process, but we know that it is used to confirm your conclusion or hypothesis about the population parameter. So through hypothesis testing, you can determine whether there is enough evidence to conclude if the hypothesis about the population parameter is true or not. Now there are two types of hypothesis in hypothesis testing. The first one is null hypothesis, which is represented by H0, which represents the prevailing belief about the population, and it assumes that status quo or existing state of affairs is true. And there is another which is called as alternate hypothesis, or represented by H1, which represents the claim that opposes the null hypothesis. And here in hypothesis testing, we are trying to prove alternate hypothesis is correct. Now we will understand this with the help of example. Now let's say that there is a criminal trial going on against a person, and there are only two possible outcomes from this trial. That is, either the person is found innocent or he is found guilty. Now guys, the law says until the person is found guilty, he is innocent, right? So after the trial only we will be knowing whether he is actually guilty or not. Until that, he is innocent. So the prevailing belief or the status quo of this is innocent. Okay, so this becomes H0 or null hypothesis, and just opposite of this is guilty. So this becomes the alternative hypothesis. And as hypothesis testing says, we are trying to prove the alternate hypothesis, which is we are trying to prove him guilty. Now we have seen this earlier also. We'll take an example of food product containing excess lead. Okay, so the null hypothesis or H0 here becomes the average lead content is within allowed limits of 2.5 parts per million. And alternative hypothesis says average lead content is more than 2.5 parts per million, and we are trying to prove alternate hypothesis here, right? Now we can have two conclusions after the testing. That is, if there is enough evidence to support the alternate hypothesis, then we will reject the null hypothesis, which is H0. And if there is not enough evidence to support the alternate hypothesis, then we say that we are failing to reject the null hypothesis. Okay, in this case we always say we fail to reject the null hypothesis. Under no condition we say that we accept the null hypothesis. So we will always try to prove H1 in terms of H0. So if good evidence is found to prove the alternate hypothesis, we will reject the null hypothesis. If we do not have enough evidence to prove the alternate hypothesis, then we fail to reject the null hypothesis. Now let's see another example of this. So let's say that the average demand of AC units per store per month is depicted by this chart, where the mean is 350 sales per month. Okay, so the historic demand says that 350 units per store per summer is sold. Okay, so here the null hypothesis becomes that mu is equal to 350. Okay, so this assumes that status quo is true, right? And H1 here becomes that mu is not equal to 350. Correct? So this assumes that mean AC sales per store is not equal to 350 units. And let's say that there are not enough evidence to prove this theory. that is the alternate hypothesis. Now, even if we are unable to reject the null hypothesis, which is this, it doesn't imply that we are accepting the null hypothesis, because there is a lack of sufficient evidence, correct? So this is the primary reason we say we fail to reject the null hypothesis. Now guys, there are some symbols that we need to take into account in order to identify the null hypothesis and the alternate hypothesis in the question. Okay, so null hypothesis always has the following signs, that are equal or less than equal or greater than equal. Okay, and the alternate hypothesis always has the following sign, which is not equals or greater than or less than. So from this example also you have seen that h1 has not equal symbol, and therefore h0 becomes equals, or vice versa. Now guys, you have to keep this in mind. We will solve some questions using this, and this will be really useful for you. Now to understand the things better, I have created two situations. So can you guys identify what will be the alternate hypothesis and the null hypothesis in each of these situations? Just pause the video here and try to identify these. Now the first situation says Flipkart claimed that its total valuation in December 2016 was at least $14 billion. So as we saw the symbols previously, the greater than equals to, less than equals to and equal symbol comes in null hypothesis, correct? So here total valuation greater than equals to $14 billion will become the null hypothesis, and alternate hypothesis will be total valuation less than $14 billion. Now similarly, the situation second says Flipkart claimed that its total valuation in December 2016 was greater than 14 billion. Okay, so greater symbol comes in the alternate hypothesis. So total valuation greater than $14 billion, and here it will be total valuation less than equals to $14 billion. Now to summarize this, you cannot decide the status quo or formulate the null hypothesis from the claim statement, and we need to take care of the signs. So now that we have decided the null hypothesis and the alternate hypothesis, we need to make a decision based on some criterias. Okay, so in order to make a decision, we would need some way to identify if a person is saying true or saying false. We will understand this with the help of example. Okay, so let's say that Apurva claims to have scored an average of 70 in archery in some competition. So this is the claim that she is doing. Now we were not there in the competition, so we don't know whether she is telling truth or lying. So what we do is, in front of ourselves, we will ask her to play 5 games, and from these 5 games we will note the scores of that and calculate the average. So let's say that we do this, and while doing this, if she has scored 20 as the average of 5 games, then we say that scoring 70 for her is very less likely to happen, and therefore we can't believe her claim. But let's say that she has scored an average of 65 in the 5 games, then we are more likely to believe in her claim of 70 in the competition. Okay, so possibilities can be she plays 5 games and gets an average of 70. Second can be she plays 5 games and get a score in one of the game as less than equals to 70, but not in all the games. And the third possibility can be she doesn't even score 70 or more once in 5 games. Okay, so any of the games she does not score 70. Now what we have to do is we have to find a critical point below 70, achieving which we can say that she can at least get 70 as an average, and therefore we have to mark these critical points in the graph. Okay, so these critical points are called as lower critical value or point and upper critical value or point. Okay, so lower critical value you can see here, and upper critical value is also pointed out in this graph, and this is called as the critical region. Okay, so the values in the graph or area under the curve till this point is called the critical region, and beyond UCV also it is critical region, and the region in middle is the acceptance region. So basically, if the sample mean lies in this region, then we can say that we would fail to reject the null hypothesis, and if it falls in the critical region, that is lower than LCV and upper than UCV, then we will reject the null hypothesis. Okay, so in short, if LCV is greater than the sample mean or sample mean is greater than the UCV, we will statistically reject the null hypothesis. And if the mean is lying between the LCV, that is, it is greater than the LCV and less than the UCV, then we will say that we fail to reject the null hypothesis. So this indicates that if the sample mean is not falling inside the critical region and it is falling inside the acceptance region, then we will fail to reject the null hypothesis. Thus, critical region gives you a statistical reason to reject the null hypothesis. Now let's say that we have counted the scores of Apurva and the sample means comes out to 50 and the population is 70. So can you just pause this video and tell me what did you conclude from this? Now as per the things we have learned, we can conclude that null hypothesis here becomes mu equals to 70 and the alternate hypothesis is mu is not equals to 70. And since sample mean is 50, that is, it is lying below LCV, this condition holds true. That is, LCV is greater than the sample mean and therefore we reject the null hypothesis in this case. That is, we can clearly say that Apurva is lying. Now critical regions like LCV and UCV not always lie on both sides but depends upon the nature of alternate hypothesis. Okay, so alternate hypothesis can be directional or non-directional. Now this example which we have seen is an example of non-directional test where null hypothesis is mu is equals to 70 and alternate hypothesis is mu is not equals to 70. And the critical point lies on both sides of the distribution, and so it is also known as two-tailed test because these signify the tails of the distribution. Now there can be scenarios where the null hypothesis is mu is greater than equals to 70 and alternate hypothesis becomes mu is less than 70. In that case it becomes directional test or one-tailed test, also known as lower tail test, because the critical region lies on the left side of the distribution, that is the LCV. And likewise there is another directional test when the null hypothesis becomes mu is less than equals to 70 and alternate hypothesis is greater than 70. So this is also known as one tail test, but it is the upper tail test because in this case it is lying near to UCV or the upper end of the distribution. Now upper tail test is majorly used in manufacturing industry. So we have seen this example also previously where the max amount of lead allowed is 2.5 parts per million. Okay, so here null hypothesis becomes mu less than equals to 2.5. Okay, so anything below 2.5 or equal to 2.5 is permissible, and the alternate hypothesis here becomes mu greater than 2.5, right? So this is again a example of one tail test or upper tail test. Now summarizing what we have learned using these examples is we have to always see signs in the alternate hypothesis, and if it is not equals to in the alternate hypothesis, it is a two-tailed test with rejection region on the both sides of the distribution. If the alternate hypothesis has greater than symbol, then it is an upper tail test with a rejection region on the right side of the distribution, and if it has a less than symbol, then it is a lower tail test with a rejection region on the left side of the distribution. So guys, this concludes our session for today. Hope this session would help you to understand some complexities around the hypothesis testing. I'm trying my best to make these videos in the simple words and along with a lot of examples, so that it helps you understand things better. So please do not forget to support my channel and subscribe and like my content, as these encourages me moving forward. In the upcoming sessions, we will be covering some more statistical tests such as p-value and z-tests. So don't forget to tune into my channel, and if you don't want to miss any updates, just hit the bell icon and you will be notified. Thanks for all your support, and I will see you in the next session. Take care and happy learning.